Hello, all my JavaScript friends. This is TheVirtuoid, aka Mike Smith, and this is our snake game. This next video, we're going to be talking about the head class. Now, what is the head class? Well, the head class represents everything we need to know or want to know about the head of the snake. As you can see on the screen here, the snake itself is basically made up of two parts, the head and the body. And the body is made up of segments, so we'll cover the body and the segments in later videos. But for this particular one, we're going to take a look at the head. So let's take a look at some code. As I said before, each one of these particular classes has its own design document, and without exception, the head has its own design document. The most important part about the head is we need to know what position it's going to be in and what the direction is going to be. And both of these are going to be vectors. So that's going to be the important thing about the constructor. Without having the position or direction, the head is kind of worthless in this particular case. We're going to have a couple of private variables called position and direction, and public variables called position and direction. As time has gone on, I really have gotten kind of rid of this private part, but that's okay because I'm basically saying all public properties will be to read only, and that pretty much guarantees you I got to have a private. But the idea here is I need to be able to read the position and the direction. Okay, what are some of the things we're going to want to be able to implement here within our head? Well, the first one is going to be move. And the move method basically says, I want you to move at a particular speed. And this is going to be important that when this particular head moves, it's going to move at a particular speed. What direction is it going to move? It's going to move whatever direction it is currently set at. And all this basically does is that once it moves, it does trigger events for wall collisions, colliding with itself, or colliding with a prize, which are the three different collisions that could occur with a snake. Because as a snake is moving forward, it could circle back along itself and hit itself, or it could hit the side of a wall, or if you got a prize that you need to hit, it can hit the prize itself. Another method we're going to take a look at is change direction, and that basically allows me to change direction. That doesn't mean it moves. It doesn't move at all. It just changes the direction itself, and we pass it in a new direction. We do validate to make sure it doesn't crash. Like for instance, if let's say you're in a 2D and you can only go north, south, east, or west, and if you're moving west, you don't want to suddenly move east because you're moving back on yourself. So it does validate whether you can actually do that or correct or not. Jump is one that we will implement a little bit later on that we haven't implemented yet. That's where you can physically jump from one position to another. I anticipate having that in the 4D environment, hint, hint. But we will get to that a little bit later. For right now, we're not going to implement it. Reset will allow me to reset the head back to its initial position. And then finally, get projected position is a new method that allows me to be able to figure out, all right, before I actually move the head, what will be the new position? And we use that to be able to help us determine whether we're going to collide with something or not. So let's take a quick look at the code. And it's very, very, very simple. And like I said, some of the methods have not been implemented itself. Let's kick that out. All right, here we go. So the constructor, again, we're passing in a position and direction. We do have another UI thing. I'm going to start working on UI here shortly, so we will be passing UI. Right now, we're not going to worry about that. I do check to make sure that each one is an instance of vector. And again, like I said in my vector video, I'm not checking for vector 2D. I'm not checking for vector 3D, just vector. So when the game initializes the head, it's going to pass it its vector. The head couldn't care less whether it's a 1D, 2D, 3D, 4D, 20D head. It just cares that it's got some sort of position and it's got some sort of direction. Here's the get position and get, oh, first of all, I'm sorry, I saved those off to my private variables, and here's the get position and get direction, which makes it read-only variables. These are two getter functions, so simple JavaScript stuff there. Here's the move. The move basically says, I'm going to get the projected path, and then I'm going to get the projected path itself, and the projected path is, we'll see that here in just a second. That will tell me what the new position is going to be for the head, and I save that off to position. And then I emit a game event called snake move, and these game events are within a singleton pattern that controls all of our eventing. And I'll be getting to that here shortly, not with this particular video. Change direction is a very simple one too. We got a new direction there. We're going to do two tests. Our first test is to make sure that we do have that it is going to be a vector, and that we are not circling back upon ourselves. And this is where we can use the we get our direction vector, and we call opposite. And opposite within all of our vectors will always return a vector, and it always returns a clone of a vector. It never returns the same vector. So basically what I'm saying here is that if the opposite of our direction equals the new direction, then we throw the error. And let's just go real quick to show you what opposite and we'll go into the 2D one to show you an example here, but let's go real quick to show you what opposite and equals looks like. And it's very, and all of them would work this exact same way. Equals just basically says, you know, return this x equals vector x and this y equals vector y. And opposite returns a new vector of this x times -1 and this y times -1. That's all the opposite does. It just gives you completely total opposite direction of what you currently have. No big deal there. And then we just basically set the new director, and then we tell the game that, hey, we got a new direction. You can do whatever you want to with it. The jump method is actually incomplete that we have right here. Right now, we're just basically setting to a new position and setting to a new direction, but it doesn't change the snake's body or anything like that. That will have to be taken care of in the snake jump. But right now, to be honest with you, jump is not quite fully implemented yet as of right now. The big one is get projected position. So we can change at different speeds here if you wish, if we wanted to. This is where we use the multiply vector method to be able, well, actually we use two of them here. We use the first of all the fill method, which will fill a vector with the number that we have there. So in this case, for a 2D one, we'll have, you know, if the speed is equal to 2, for example, and we had a 2D vector of x and y, we will have a vector that have x is equal to 2 and y equals to 2. If the speed is 4, x will be equal to 4 and y will be equal to 4. It's as simple as that. And multiply basically takes our current direction and multiply it by the speed, and that will give us what our x value is going to be and what our new y value is going to be. That's going to be our position, and then that's how far we have moved on the x-axis and on the y-axis. And we add that into position to be able to send that on, you know, to the system, and whoever calls this then will have that information. The game, except for example, will call this to be able to say, hey, I need to find out whether I'm going to, you know, hit something or not. And if I hit something, then we send out that we send out the events. Otherwise, we do an actual move by setting the position. Now, one thing I just did notice here is that in the head design here, this is because this is one of the first things I worked on. I did say here it does check to make sure we have all the collisions done. That's actually not the case. So this is one of those things that as you develop a system here, you do change designs. The snake is actually handling the collisions part of the system and not the head. The head just moves. The snake's body just moves, but the snake itself determines whether it's making a collision or not. So that's neither here nor there. So that's the other thing I want you to understand is that once you have a design, it doesn't have to be set in stone. Things can change. You know, this, for instance, once I started working on the head here, I realized this was not the right place to put these events. I needed to be at the snake level. I should have erased this and sent it up to the snake level. But that's the way it goes. So that's really all there is to the head. It's very, very simple. We have the position, we have the direction, we can move it, we can change the directions, we can jump, and we can get the projected position. What happened to reset? Well, there is no reset because, again, that's going to be done at the snake. So, again, there's something that needs to be changed. And so that's all there is to the head class. Thanks for watching. Subscribe to this channel to view more videos. Click on the like button on this video and visit us at TheVirtuoid.com. Also, support us on Patreon, where you can get access to member-only videos. Links are down below. Again, thank you very much for watching, and keep on coding.